All right, so we're looking here today at an assignment called Graphs of Motion in One Dimension. This is the assignment itself. You'll have this printed for you most likely, or else I'll have it so you can always download it. The link will take you to here. If not, of course, you can see right here, it's not complicated to find. When you get there, you'll just click play, and normally if you click here, it works. Now, if you pay attention to the instructions, it's important. You definitely should play around with this a little bit. You can see you can change his initial position, move it around. You can change some of these settings. This is a great way of just trying to understand acceleration. You can look at what's going on. This is a really, really good simulation to be thinking about when we're dealing with acceleration and initial velocity and constant velocity. One thing we could do is you could start out with an initial position of say -2. Start out with a positive velocity of say 2 or 1. Let's take it all the way to about 2. Positive velocity of 2, and then if we have an acceleration of say -1, you also can type in these squares, by the way, and you could try to predict what's going to happen. So we could click play, and you see the acceleration never changed, but yet the direction and the velocity did in terms of negative and positive. So he started going one way, and then he went back the other way. We can look at what happened again. We can do the playback. So this is a great, really great resource to look at to start trying to think about what's really happening here, especially for those folks who are more visual like I am. When you get to the assignment itself, the expectation is you go over to charts, and you're going to be working on the assignment. And the idea is really this acceleration for the entire assignment. That's not true. You're never really going to look at the graph on it, but you're going to occasionally be changing acceleration. So what you would do on your assignment, and I have some pictures here. The first thing you would do on this assignment is just go through the entire page and make this the start of a graph. Now, when we're looking at this graph, of course, this is the y-axis, and then this is the x-axis. But the first thing to do would just be to start out by making that, just go through and write all of those down. And then the next thing you would do is try to make some arrows to represent what that graph would look like based on this criteria. So if the initial velocity was 0, and by the way, I'll tell you these first couple are wrong. These are incorrect because I want to show you that. But make a prediction. It doesn't have to be right. Hopefully you'll start to get them right. It's going to be a lot faster once you get them right. But then you're going to want to set up this scenario. So initial, and then you're going to test it. So say we did this first one, initial position 0, initial velocity positive, and acceleration 0. So what that would look like is if initial position is 0, that's already 0. A lot of times you can play around with this, but probably like a 3 would work great. So you could just type 3. The initial velocity was positive 0, and then this was acceleration of 0. And then I also recommend when you're doing this, just get rid of these blocks, and I'll show you why. But then pretty much just press play and let it run for a while. Really, you're going to want to let it run until it kind of gets to the end of the screen here. It's going to be the easiest to see. And then we can pause it. And at this point in time, you basically have the answer to what you were just working on right here. So this is the position time graph. Position time goes this way. And were we right? Well, no, we actually weren't right. What about on the velocity time graph? Were we right? No, we weren't right. So what you would do then is with a bright colored pen, you would fix it. So you would say, well, here's what it should have looked like. Here's what it should have looked like in red. Okay? And so then if we go back to our second line, we could look at our second one. It says positive, positive, 0. So in this case, we could start out with, we're going to reset all. And again, you want to do away with those bricks. But if you do a positive 3, and then a velocity of 3, positive 3, you can play it again and you can watch what would happen. Then you could double check. Hey, what did my second for positive, positive, how did I do there? And you could say, well, look, actually I got that one right and I got that one right. So then what that might look like is you would just put a check mark to symbolize, yeah, I got that right. Yeah, I got that right. As you go along, hopefully you would get faster and faster at these. There's going to be some where you're going to be changing acceleration. And by the way, hitting the clear button is better than resetting all. I probably should have said that. So if you go back to, say you have a position of 5, and you have an initial velocity of, say, 2, and then you put in an acceleration of -1. Well, what would that look like? And sometimes that's going to be something you would put into this. It's important to always get rid of those bricks. And depending on the values you put in, this could happen faster or slower. This one is, I put in a pretty small value for acceleration, and so nothing's happening too fast here. But you can start to see what this, here you're starting to get a curve. And again, there's a lot of these you can do. And hopefully by the time you're done with it, it's all starting to make sense. Thank you and best wishes.